Thank you. All right, folks, are we here? Okay. So a lot of new words today, a lot of just new stuff in general. Just let it sit, ferment. We'll take care of most of the homework and such tomorrow, okay? So today we're going to be talking a lot about statements, and it's going to feel like an English class because you're literally going to be writing sentences today, okay? So first we have to define what a statement is for our class, and it's just a sentence that is either true or false. Okay, so again, a sentence, and we can decide if it's true or false. That's what a statement is. That true or false is its truth value. Its truth value. And it's kind of weird. We represent our statements with letters because it's math, right? And we typically use P or Q. And that will make sense in about 3 minutes. So just kind of hang with me for a second, okay? So our first example here, you guys see how it says P? So this is representing this statement right there. So P says, supplementary angles add to 180 degrees. Is that true or false? True. Right, you guys see how we could decide if that was true or false? So true. You're going to put a T there for its truth value, because it's true. Now, negation, you can negate something, and all you're doing, you guys, is taking the opposite truth value. So if it's true, you're making it false. If it's false, you're making it true. In symbols, it's that little squiggle, then P. And you would read this whole thing here as not P. Okay? Not P. So we're using the same statement that we had before, but we're going to make it the opposite. So we're going to say supplementary angles do not have a sum of 180 degrees. Okay, so is that true or false? True. False. It should be false, right? We just made it the opposite of this guy. It should be false. Because we know supplementary angles add to what? 180. So if we say they don't add to 180, isn't that false? Should be. Okay. Just like English, in math, you can have a compound statement, and we join them with the words and or or. And or or. If they're joined by the word and, it's a conjunction, okay? So conjunction is when we join the two statements with the word and. In symbols, the word and, logically, is this like upside down V. That's and for logic. And to determine if that statement is true or false, both parts need to be true for it to be true. Okay, disjunction is when we combined our statements with the word or. That symbol logically, it looks like the letter V. So P or Q. And then at least one has to be true for the whole thing to be true. One could be false, but as long as one is true, your whole overall statement is true. Now, when I see these symbols, how I remember if this is and or, when I make my A's, I make them like that, and that looks like the symbol for and, right? That's how I think that this looks like a capital A in my brain. That's how I remember that one's and, whereas this one is or. That's an or, and. That helps you, awesome. If not, that's just my little trick, okay? I know that was a ton of information on this page, but it will make sense now when we try some examples, okay? So here we go. We're going to be writing some statements here, okay? So the first thing we want to do is decide if our statements are true or false, okay? So based on that figure, let's read what they say. It says, the figure is a triangle. Is that true or false? True. True. And I'm going to put a little T by there so I don't have to think about it later. So that's true. The figure has two congruent sides. How do we know? Those tick marks, yep. So that's another true. And then the figure has three acute angles?
No.
Right, because we have what kind of an angle in there? Perfect. So now that we've decided if they're true or false, it makes that part much easier in the end, okay? What symbol is right here? And. So now we're going to write P and R. So what's P?
True.
Nope, what is the whole statement?
The figure is a triangle.
So that's what you're going to write first. The figure is a triangle. Write that out. The figure is a triangle. So that was P. We wrote that first. And then what word's connecting them? And. So write the word and. And then we write what R says, which is what?
The figure has 3 acute angles.
Yeah, I'm not going to write the figure twice. I'm just going to write and has 3 acute angles. And now we have to decide if that statement is true or false. So what I like to do is what's P? Is P true or false?
True.
So I'm going to put a little T there. What's R?
False.
False. Now for an and statement, how many have to be true for the whole statement to be true?
Both.
Both. So what's our truth value?
False.
False. That was a lot. Was it okay?
Yeah.
It gets kind of hairy. Okay. Let's try another one. So this says Q and not R, right? So what's Q?
The figure has 2 congruent sides.
So that's what we're going to write first. The figure has 2 congruent sides. And that's our connecting word. How do we write not R? And doesn't have
3 acute angles.
perfect. And does not have 3 acute angles. Yeah.
Do we have to write this all out every time we do something like this?
Yeah, every time you gotta write the whole thing out. I know. It's kind of a pain in the butt. But I didn't invent it. I'm just here to relay the knowledge that I know to you. So that's what the state tells me to do. Okay, let's come back here. What's the truth value of Q?
True.
True. What's the opposite truth value of R?
True.
True. So our overall truth value?
True.
Beautiful. Okay, you guys do the last one and I'll catch up to you. See how it goes and I'll type it out up here. Anyone want to share what they wrote? Sure.
The figure is a triangle and the figure has 2 complete sides.
Perfect. True or false?
True.
Are we okay? Okay, let's flip it. I promise we won't do all 3 ors, but let's just pick a few, okay? Let's try a few disjunctions. Okay, step 1, let's decide if those P, Q, and R's are true or false. So P says, January is a fall month.
False.
False. January only has 30 days.
True.
I'm not sure.
You guys do the thing on your knuckles? If it's on top of your knuckles, it's 31. January, so there's 31. February, March, April, May, June, July, August, September, October, November.
What?
Should we all learn this right now? Okay. You use your hand, your knuckles. Start like right here. So January falls on top. So there's 31. January. February is between your knuckles. So there's 28 days. Okay. March, April, May, June. And then you're gonna come back here. July. Can't do this. August, September, October, November, December. So if it falls between your knuckles, there's not 31 days in that month. Fun fact, we don't just learn math in here.
Why?
I can show you later. That was confusing. Okay, that one is false. Okay, January 1 is the first day of a new year. True. Okay. Here we go. So same thing. Q, and this symbol is or. Yeah, or. Yeah, Q or R. So here we go. Q says January only has 30 days. Or R, January 1st. Whew, that's a long one. Okay, let's write out what our truth values were. Okay, what was Q? False. What was R? True. For an or, how many need to be true for the whole thing to be true? So then our truth value is true. Okay, do you guys want to do the middle one or the last one? Okay, let's do the last one and we'll skip the middle one. Try the last one, okay? And then we'll compare. Anyone want to share out? January is not a fall month, or January 1st is the first day of a new year. Is that what you guys put? True or false? True. Should be true? Am I wrong? Is one of them at least true? R is, right? Okay. Okay, we have a conditional statement. So we had statements like we just saw there, and now we have something called a conditional statement. And all that is, you guys, is taking your regular statement and writing it in if-then form. That's what a conditional statement is writing it in if-then form. So in symbols, it's a P, then an arrow, and then Q. And how you read that is P implies Q. P implies Q. The hypothesis is the phrase immediately after the word if, and the conclusion follows the word then. So a conditional statement is just a statement in if-then form. So let's practice taking a regular statement and then writing it in if-then form, okay? So our first statement is a mammal is a warm-blooded animal. How can we change that so it's if-then form? And there's more than one right. Yeah, JC.
If an animal is warm-blooded, then it's a mammal.
Perfect. If an animal is warm-blooded, then it's a mammal. Okay, what about 4 quarters can be exchanged for a dollar bill? Don't overthink it. If Mason.
If you exchange 4 quarters and you get $1.
Yeah. You have 4 quarters. Bless you. Then you can exchange it for a dollar bill. You guys try that last one on your own and then we'll compare. Anyone want to share what you put? Silas?
If the sum of the measures of two supplementary angles, it is 180, or then it's 180.
Yep, if 2 angles are supplementary, then their measures is 180. Yep, did anyone write the opposite, like the reverse order? You could have either way. I wrote it the same way as Silas. If 2 angles are supplementary, then the sum of their measures is 180 degrees. Okay, the last part on that page is kind of important. We can take these if-then statements and decide if they're true or false, okay? I have a typo. Will you guys change this first much to must? So if we read this, it says to show a conditional is true, you must show that for each case when the hypothesis is true, the conclusion is also true. To show that conditional is false, you only need to find one counterexample. So you guys underline counterexample. So if it's false, you have to say, give a reason for why it's false. A counterexample. Now, will you guys star this second paragraph? It's kind of confusing. When the hypothesis of a conditional is not met, the truth of the conditional cannot be determined. When the truth of the conditional statement cannot be determined, it's considered true by default. You guys underline that? So if a statement is not false, logic dictates it must have to be true. So to break that down, if your hypothesis is false, the statement's automatically true by default. We'll see how that sits. All right, let's try it. If you divide an integer by another integer, the result is also an integer. Is that true or false? You guys know what an integer is? It's a number. What kind of a number? Any whole number, positive or negative. So if you divide a whole number by another whole number, does it always give you a whole number? No, so we're gonna say false. But because it's false, we have to give a counterexample. Give me an example.
7 divided by 3.
7 divided by 3. Do we get a whole number? Nope. What, 2 1/3? It's not a whole number. Perfect. If next month is August, then this month is July. True. Why is it true? Perfect. That's what you're going to say. August comes after July. If a triangle has 4 sides, then it's concave. You want to say false, right? Because we know a triangle doesn't have 4 sides, but since we can't prove the conclusion's false, it's true by default. It's true by default. That's what we just kind of went over in that little paragraph. True because the hypothesis is false. True by default. Do we need to take a second to stand up? You guys doing okay? Okay. Last little bit here is we can rewrite our conditional statements. A converse is when you switch the order of the hypothesis and conclusion. So your converse is when you flip the order. Inverse is when you negate them. So not P implies not Q. We're going to not them. Not P implies not Q. And then the contrapositive is both. We're going to switch the order and negate them. So not Q implies not P. This looks a lot scarier than this is. This is not hard. This will be fine. So let's try one example by doing these 3 things, okay? So it says write the converse, the inverse, and contrapositive of the statement below and determine its truth value. So it says lions are cats that can roar. How can we write that as an if-then statement? If what? Can we be more general? Can you say if an animal is a lion, then it's a cat that can roar? So that's our if-then statement. Okay, now converse, what do we do to our order? Flip it, so it's Q implies P. So what would that look like? If an animal is a cat that can roar, then it's a lion? Perfect. So let's write that. There's a lot of writing, I know, you guys. Is that one true or false? Oop, a car. That doesn't make sense. A cat. that true or false?
False.
Why is it false?
Tigers.
Tigers can also roar. Okay, what do we do in an inverse? What's our little code? What do we do for an inverse? Negate them, right? So what does that look like? Perfect. If an animal is not a lion, then it is not a cat that can roar. Is that one true or false?
False.
Why is it false? Tiger? Yep. Okay, last one for today. What's our contrapositive?
Not a cat that can roar, then it is not a lion.
Okay, before that, what's our symbols? Not Q implies not P. What do you guys think on that one? True or false? If an animal is not a cat that can roar, then it's not a lion.
True.
That one is true, right? If it can't roar, then we know for sure it's not a lion, right? Maybe this is something you want to write in your notes. A converse and an inverse will have the same truth value. They're logically equivalent. I don't know if you, I probably put that somewhere in my notes. Converse and inverse will have the same truth value, and your contrapositive and your conditional will have the same truth value. Because this one would have been true if we would have said that. So that's a way to check yourself. Converse, inverse will have the same truth value. Contrapositive and conditional will have the same truth value. That was a lot. And I realize that and I apologize.